Hello, my name is Ed Nallen, and this is my presentation on testing software for software engineering at SUNY Old Westbury. So, what is software testing? Software testing is the act of checking whether software satisfies expectations. Software testing can provide objective, independent information about the quality of software and the risk of its failure to a user or sponsor. Software testing can determine the correctness of software for specific scenarios, but cannot determine correctness for all scenarios. It cannot find all bugs. The goals of software testing are, of course, finding bugs when you can, ensuring requirements are satisfied, and code coverage. Categorization of software testing. There's automated testing, using software to separate from the software being tested to control the execution of tests and the comparison of actual outcomes with predicted outcomes. There are different levels of testing. There's unit testing, which is testing individual units of code. Integration testing, which is a type of software testing where components of the software are gradually integrated and then tested as a unified group. And then the largest is system testing, which examines every component of an application to make sure that they work as a complete and unified whole. There's static testing, which is implicit, like proofreading, and dynamic testing, which takes place when the program itself is run. Passive testing is verifying the system's behavior with any interaction with the software product. There's also exploratory testing, an approach to software testing that is concisely described as simultaneous learning, test design, and test execution. There's also white box testing and black box testing. And as you can see here, there's a nice little picture about the different kinds of tests, and it's a nice little diagram of a triangle pyramid type thing where, as you see on the lower level, the unit tests have a huge number of tests, but a very low execution time because they can be executed rapidly, which is very important, the rapidity of the testing, and we'll get into that later. There's white box testing versus black box testing. White box testing verifies the internal structures or workings of a program, as opposed to the functionality exposed to the end user. In white box testing, an internal perspective of the system, the source code, as well as programming skills, are used to design test cases. The tester chooses inputs to exercise paths through the code and determines the appropriate outputs. Black box testing describes designing test cases without knowledge of the implementation, without reading the source code. The testers are only aware of what the software is supposed to do, not how it does it. Software testability. Now, software testability is the degree to which a software artifact, a software system, a software module, requirements or design document supports testing in a given test context. If the testability of the artifact is high, then finding faults in the system by means of testing is easier. What factors determine the testability of software components? There's controllability, the degree to which it is possible to control the state of the component under test, or the CUT, as required for testing. There's observability, the degree to which it is possible to observe test results, both intermediate and final test results. Isolatability, the degree to which the component under test, again referred to as the CUT, can be tested in isolation. Separation of concerns is the degree to which the component under test has a single, well-defined responsibility. Understandability, the degree to which the component under test is documented or self-explaining. Automatability, the degree to which it is possible to automate testing of the component under test. And heterogeneity, the degree to which the use of diverse technologies requires the use of diverse test methods and tools in parallel. Testability of software components can be improved by using test-driven development, or TDD, and designing programs with testability in mind. Requirements for testability. We have consistency, completeness, unambiguity, they have to be quantitative, and they have to be verifiable in practice. Now, what is unit testing, which is probably the most important form of testing? Unit testing, also known as component or module testing, is a form of software testing by which isolated source code is tested to validate expected behavior. Unit generally implies a relatively small amount of code that can be isolated from the rest of the code base, which may be a large and complex system. In procedural programming, a unit is typically a function or module. In object-oriented programming, a unit is typically a method, object, or class. Okay, the history of unit testing. Unit testing became a signature activity of extreme programming, or XP. Unit testing quickly led to test-driven development, or TDD. Unit tests are usually written these days by programmers themselves using regular tools, the only difference being the use of some sort of testing framework to encapsulate the program. Why? Why would we bother? So unit tests are fast. You can run them several times a minute after changing code, so you immediately know if you broke something, which is very important for testing and for coding in whole, because debugging is one of the biggest time sinks in coding. Test suites are the logical grouping or collection of test cases to run a single object with different test scenarios. You trade off the depth of testing with how long it takes to run the test suite, also known as the compile suite. The test is quick because it only tests a small unit of code. If you are using continuous integration, you should run a test suite as a part of it. We're going to call this a commit suite because it's used, you run it before you commit the changes to the larger program. It's common for this suite to include all the unit tests. You should run the commit suite several times a day, especially before any shared commit to version control, as I was saying before. Test suites should generally run fast enough so that you're not discouraged from running them frequently enough. And frequently enough is so that when they detect a bug, there's a sufficiently small amount of work to look through so you can find it quickly. Now, test-driven development, or TDD, is a technique for building software that guides software development by writing tests. It was developed by Kent Beck in the late 90s as a part of extreme programming, and it follows 3 steps repeatedly. You write a test for the next bit of functionality you want to add. You write the functional code until the test passes. Then you refactor both old and new code to make it well structured. So this form of programming, you actually write the test before you do any of the code so that it's easier to tell if it passes. And that way you can think about how you want the code to work to pass the tests. The benefits of test-first programming. It's used as a way to get self-testing code since we can only write some functional code in response to making a test pass. Thinking about the test first forces us to think about the interface to the code first. This focus on interface and how you use a class helps us separate interface from implementation. There's also a nice little diagram that I found online here depicting test-driven development. So you pick a test, you write the test, you make it pass, and then you refactor. Types of unit tests. There are sociable tests preferred by classical X-unit testers. The test unit relies on other units to fulfill its behavior. Solitary tests are preferred by mockist X-unit testers. Some unit testers prefer to isolate the tested unit. The use of test doubles or replacing a production object for testing purposes. Okay, so now we have classic versus mockist testing. Classical TDD, also known as Detroit style. This style of testing is to use real objects if possible, and a double if it is awkward to use the real thing. Mockist TDD, aka London style. In this style, the tester will always use a mock object for any object with interesting behavior. Test double is a generic term for any kind of pretend object used in place of a real object for testing purposes. Mock objects describe special case objects that mimic real objects for testing. The types of test doubles. So first off, we have a dummy. Objects are passed around but never actually used. Usually they're just used to fill parameter lists. A fake. Fake objects actually have working implementation, but usually take some shortcut which makes them not suitable for production, as like in in-memory database is a good example. In-memory database runs entirely in main memory without touching a disk. Often they run as an embedded database created when a process starts, running embedded within that process, and destroyed when the process finishes. Then there are stubs. Stubs provide canned answers to calls made during the test, usually not responding at all to anything outside what's programmed in for the test. Spies are stubs that also record some information based on how they were called. One form of this might be an email service that records how many messages it was sent. Mocks are objects pre-programmed with expectations which form a specification on the calls they are expected to receive. Mocks insist upon behavior verification. Other doubles can, and often do, use state verification. State verification is we determine whether the exercise method worked correctly by examining the state of the SUT, or system under test, and its collaborators after the method was exercised. It's used by classical testers. Behavior verification is the ability for instrumenting and verifying its interactions with other objects or other parts of the system. We do this by telling the mock what to expect during setup and asking the mock to verify itself during verification. Obviously, we've said mock a lot. It's used by mockist testers. And the system under test is the object that is being tested. Testing with JUnit. JUnit is an open source Java library designed specifically for unit testing. JUnit is not part of the standard Java class libraries. It is included in several IDEs, and JUnit provides automated testing and validation. JUnit provides tools to unit test all aspects of a program. JUnit does not work for integration or performance testing. Now, assertions in JUnit. JUnit provides overloaded assertion methods for all primitives, objects, and arrays of primitives or arrays of objects. Parameter order is expected value and then actual value. A string message can also be added as a first parameter. Assertions can be used to compare expected and actual values for array, single values, objects, and null values. Aggregating tests into a suite. You can combine several classes into a test suite and test them all at once. Test suites run all specified classes in the suite in that order. A test suite can contain other test suites. Basic unit tests. JUnit does not require human judgment to interpret. It automatically checks the expected result against the actual result and interprets it. It's easy to run many test cases at the same time and to generate test suites, which is a suite that allows for aggregation of testing all classes at the same time. JUnit tests can take arguments and test the code with those arguments you gave it. Suite uses aggregate syntax and allows multiple classes to be run at one time. Now, into the meat and potatoes here. We got JUnit 5. JUnit 5 is the JUnit platform plus JUnit Jupyter plus JUnit Vintage. So platform serves as a foundation for launching testing frameworks on the JVM, or Java Virtual Machine. It also defines the test engine API for developing a testing framework that runs on the platform. Provides a console launcher to launch the program from the command line, and the JUnit platform suite engine for running a custom test suite using one or more test engines on the platform. Jupyter is the combination of the programming model and extension model for writing tests and extensions in JUnit 5. Vintage provides a test engine for running Java Unit 3 and 4 based platforms. All right, now we have some annotations for JUnit 5. We have @test, which denotes that the test is a test method. Unlike JUnit 4's test annotation, this annotation does not declare any attributes, since test extensions in JUnit Jupyter operate based on their own dedicated annotations. Such methods are inherited unless they are overridden. Then we have a parameterized test, which denotes a test method that is a parameterized test. Such methods are inherited unless they are overridden. Repeated test denotes that a method is a test template for a repeated test. Such methods are inherited unless they are overridden. Test factory denotes that a method is a test factory for dynamic tests. Such methods are inherited unless they are overridden. Test template denotes that a method is a template for test cases designed to be invoked multiple times depending on the number of invocation contexts returned by the registered providers. Such methods are inherited unless they are overridden. Test class order, used to configure the test class execution order for @nested test classes in the annotated test class. Such annotations are inherited. Test method order, used to configure the test method execution order for annotated test classes. Such annotations are inherited. And test instance, used to configure the test instance lifecycle for the annotated test class. Such annotations are inherited. Display name declares a custom display name for the test classes or test methods. Such annotations are not inherited. Very important. Display name generation declares a custom name display generator for the test class. Such annotations are inherited. Now we have some that are very similar, so I'm not going to read every single one. Before each denoted that the annotated method should be executed before each test, repeated test, parameter test, or test factory method in the current class. Such methods are inherited unless they are overridden or superseded. After each does the same thing as before each, except that the annotated method should be executed after each test, repeated test, etc. Before all denotes that the annotation method should be executed before all of the test, repeated test, etc. And after all denotes that the annotated method should be executed after all test, repeated test, etc. Then we have @nested, which denotes that the annotated class is a non-static nested test class. On Java 8 through Java 15, before all and after all methods cannot be used directly in a nested class unless the per class test instance lifecycle is used. Beginning with Java 16, however, before all and after all methods can be declared as static in a nested class with either test instance lifecycle mode. Such annotations are not inherited. Then we have @tag, used to declare tags for filtering tests, either at the class or method level. Such annotations are inherited at the class level, but not at the method level, which is surprising. @disabled is used to disable a test class or test method. Such annotations are not inherited. at timeout, used to fail a test, test factory, or test template, or lifecycle method, if its execution exceeds a given duration. Such annotations are inherited. Extend with, used to register extensions declaratively. Such annotations are inherited. Register extension, used to register extensions programmatically via fields. Such fields are inherited unless they are shadowed. And then at temp dir, used to supply a temporary directory via field injection or parameter injection in a lifecycle method or test method. JUnit Jupyter annotations can also be used as meta annotations. You can define your own composed annotations that will automatically inherit the semantics of its meta annotations, which is very cool. Concept definitions. Platform concepts, like a container, which is a node in the test tree that contains other containers or tests as its children, for example, a test class, and test, a node in the test tree that verifies expected behavior when executed. Example, at test method. Jupyter concepts. There's a lifecycle method, any method that is directly annotated or meta-annotated with at before all, at after all, at before each, or at after each. More definitions. Test class, any top-level class, static member class, or at nested class that contains at least one test method, i.e. a container. Test classes must not be abstract and must have a single constructor. Test methods. A test method is any instance method that is directly annotated or meta-annotated with at test, at repeated test, parameterized test, test factory, or test template. With the exception of at test, these create a container in the test tree that groups tests, or potentially for test factory, other containers. Test methods and lifecycle methods may be declared locally within current test class, inherited from superclass, or inherited from interfaces. Test classes and test methods can declare custom display names via @displayName with spaces, special characters, and even emojis that will be displayed in test reports and by test runners and IDEs. JUnit Jupyter supports custom name generators that can be configured via the @displayName generation annotation. Values provided via @displayName annotations always take precedence over display names generated by a display name generator. Generators can be created by implementing display name generator. You can use the JUnit.Jupyter.displayName.generator.default configuration parameter to specify the fully qualified class name of the display name generator you would like to use by default. Default generators that are available in Jupyter. Standard matches the standard display name generation behavior in place since JUnit Jupyter 5.0 was released. Simple removes trailing parentheses for methods with no parameters. Replaces underscores with spaces. And indicative sentences generates complete sentences by concatenating the names of the test and the enclosed classes. Okay, now JUnit 5 assertions. There's assert all, assert equals, assert not null, assert throws, assert timeout preemptively, and assert true. You can also use third-party assertion libraries such as AssertJ, Hamcrest, and Truth. There are two JUnit 5 assumptions, assume true and assuming that. And obviously by using assume true, you can also assume that something is false by having it fail the assume true test. More definitions. Disabling tests. Entire test classes or individual test methods may be disabled via the @disabled annotation, via one of the annotations discussed in the conditional test execution, or via a custom execution condition. Conditional test execution is an extension that allows developers to either enable or disable a container test based on certain conditions programmatically. Tagging and filtering. Test classes and methods can be tagger via the @tag notation. Those tags can later be used to filter test discovery and execution. Test execution order. By default, test classes and methods will be ordered using an algorithm that is deterministic but intentionally non-obvious. This ensures that subsequent runs of a test suite execute test classes and test methods in the same order, thereby allowing for repeatable builds. Test inheritance lifecycle. In order to allow individual test methods to be executed in isolation and to avoid unexpected side effects due to mutable test instance state, JUnit created a new instance of each test class before executing each test method. Nested tests give the writer more capabilities to express the relationship among several groups of tests. Dependency injection for constructors and methods. In JUnit Jupyter, both test constructors and methods are now permitted to have parameters. This allows for greater flexibility and enables dependency injection for constructors and methods. Even more definitions. We have test interfaces and default methods. JUnit Jupyter allows @test, @repeated test, @parameterized test, test factory, test template before each and after each to be declared on interface default methods. Before all and after all can be declared on static methods in a test interface or on interface default methods if the test interface or test class is annotated with @test instance parentheses lifecycle dot per underscore class end parentheses period. Repeated tests. JUnit Jupyter provides the ability to repeat a test a specified number of times by annotating each method with repeated test and specifying the total number of repetitions desired. Parameterized tests make it possible to run multiple times with different arguments. Test templates. A test template method is not a regular test case, but rather a template for test cases. As such, it is designed to be invoked multiple times, depending on the number of invocation contexts returned by the registered providers. Dynamic tests are generated at runtime by a factory method that is annotated with @test_factory. In contrast to @test methods, a test factory method is not itself a test case, but rather a factory for test cases. Thus, a dynamic test is the product of a factory. Timeouts. The timeout annotation allows one to declare that a test, test factory, test template, or lifecycle method should fail if its execution time exceeds a given duration, and parallel execution. By default, JUnit Jupyter tests are run sequentially in a single thread. Running tests in parallel, for example, to speed up execution, is available as an opt-in feature since version 5.3. To enable parallel execution, set the junit.jupyter.execution.parallel.enabled configuration parameter to true. Now the moment we've all been waiting for, the conclusion. Testing is very important to software development. Running unit tests on your code frequently makes it easier to find and fix bugs before they are committed. JUnit 5 is a powerful tool that will help developers perform unit tests on their code. Thank you. Was that there the whole time? Excellent.